clinging on to all the phosphorus and change the system from a nitrogen-limited system to a phosphorus-limited system. And so I'm going to return to this conceptual figure throughout the rest of the talk. And just a brief outline of what I'm talking about is within a stream system, everything is first set by the physiochemical structure. So the underlying geology, the discharge of the system, the temperature, the nutrient availability. And this influences the community structure. So what organisms you find there, the density of them, their body size. And collectively, these two influence the species traits that are available within the environment, such as their physiological traits. But I'm going to focus primarily on their tissue stoichiometry, so their carbon, nitrogen, phosphorus ratios. And this is going to influence what they're excreting back into the environment and what they're storing. And then collectively, this is going to have a net effect on the availability of nutrients into the system, which will feed back to the physiochemical structure and the community structure. So the first question I wanted to address is, what is the overall effect of mussels on nutrient demand? Are they a net source or sink? So for this study, I had 9 sites within 3 rivers in southeastern Oklahoma, in the Kiamichi, the Little, and the Mountain Fork rivers. And this is kind of what the system looks like. It's within this mountain range called the Washita Mountains, so these kind of low hills. It's a relatively flat river, but some gradient. And this is one of my sites that was packed with mussels. This had more than 35 mussels per meter squared within this little area right here, about 100 meters stretch. And so for this, I measured aerial excretion. And this is the actual amount of nutrients organisms are excreting into the environment. So to make this more simple than saying remineralizing, this is what they're peeing back into the system, okay? And this makes nutrients readily available. Algae can take it up, bacteria, so this is really influencing the productivity of the system. And to calculate aerial excretion, you take the biomass of the organism per meter squared times their nutrient excretion rate. So how much nitrogen's in their pee when you measure it over an hour, okay? And then I also measured nutrient storage. So this is the mass of nutrients stored in the body tissue. So I took a sample of their tissue and I analyzed it for carbon, nitrogen, and phosphorus. And you can think of this as a nutrient sink within the system.